Hello everybody, and welcome to page 28 in the workbook. And this is the end of the section that we're currently working on. Just going to state some theorems about linear dependence and independence. Okay, so we'll start with theorem 1.6. Let's read this together. Okay, we're not going to prove this theorem, but we can think about kind of why it conceptually makes sense. Okay, so it tells us let V be a vector space with S1 a subset of S2 a subset of V. Okay, so if we drew a picture of this, it would kind of look like, okay, we've got our big vector space here, and then S1 is a set that's inside of S2, so maybe S2 looks like this, and then S1 is inside. Okay, here comes the theorem. So it says if S1 is linearly independent, then S2 has to be linearly independent. Or I'm sorry, if S1 is linearly dependent, then S2 has to be linearly dependent. Now, why is that? Okay, why does that make sense? Well, saying that S1 is linearly dependent means that if we look inside the smaller set, S1, there have to be some dependencies in there. In other words, there are vectors in S1 that depend on other vectors in S1. But if that statement is true in the smaller set, if there are dependencies in the smaller set, then there certainly have to be those same dependencies in the bigger set. So logically, theorem 1.6 makes sense, and if we were going to write a proof, we would kind of base the proof on that intuition that we just described. Okay, now let's read the corollary to theorem 1.6. Okay, so it starts us with the same setup, and then says if S2, the larger set, is linearly independent, then the smaller set S1 is linearly independent. And I'm curious, do you see a relationship between the corollary and theorem 1.6? Think basic logic here. Okay, so theorem 1.6 is kind of the form if A, then B. And if you look at the corollary, notice that it has the form if not B, then not A. Okay, you recognize that sort of thing? Okay, the corollary is really just the contrapositive of the statement of theorem 1.6. I'm going to write that down here. Okay, let's clear a little clutter away. Okay, and you might remember learning in Math 220 or its equivalent that a theorem and its contrapositive are logically equivalent to each other. And so if we prove theorem 1.6, then the corollary has to automatically be true because it's the contrapositive of theorem 1.6. Okay, and then finally, theorem 1.7. Okay, let's read this together. Let S be a linearly independent subset of a vector space V, and let V be in V, but not in the set S. And it says that the set S union V is linearly dependent if and only if V is in the span of S. I'm hoping that you recognize that as being similar to the problem that we just did in the previous video. Okay, in fact, it's logically equivalent to that. Okay, so we didn't write a proof of this, but we kind of gave a little bit of intuition as to why it might be plausible to think that this might be true. Okay, and I'm feeling really lazy today, so I'm not going to write the proof of this, and just mention that it's in the notes. Okay, so if you're interested, feel free to give it a read. Okay, and we're done with this section.